Alright, so in this video we go over section 2.1, solving linear equations in one variable. So first of all, let's define what a linear equation in one variable is. So it's an equation of this form: ax plus b equals some number c, where the power, that is the exponent of the variable x, is power 1. Otherwise, if we had power 2, those will be quadratic equations, or power 3 cubic equations. Well, we're going to look at those equations later on. Examples of these types of equations are, for example, I don't know, maybe 3x plus 5 equals to 0, 1/3 x minus 4 equals to 7, for example. Those are examples of linear first order equations. Linear equations in one variable. So in this case, well, we're going to look at two properties for solving equations. Number one, the addition or subtraction property. That is, essentially, when we have an equation, we can add or subtract some quantity as long as we do it on both sides of the equation. Right now, this looks like all symbols. Well, let me give you just one example. So if we have x minus 3 equals 5, for example, we are going to add a number c to get the x isolated. For example, I need to add 3. And that way we can cancel. That's what we're going to use this property for. And then we have the multiplication property. Let me give you another example. So we can multiply both sides of an equation as long as we don't multiply by 0. That's the condition here. And we have to do it on both sides. For example, if I have 1/3 x equals to 5, I'm going to multiply both sides by some number c in a way that I get the x by itself. That is, I'm going to multiply both sides by 3. So if I multiply one side by 3, I have to do it on the other side as well. And this is how they cancel. So the best way to see these two properties or definitions in action is by actually looking at the example. So let's move on to the next page. So what do we have? Well, let's solve each equation here. So the goal here is to isolate the x. Alright, I want to get rid of this 5, and then I'm going to get rid of this 2. So I'm going to do the inverse of adding a 5. So the inverse of adding a 5 will be subtracting 5. But if I subtract one side, I have to do it on the other side as well. And that's going to give me, well, so over here they cancel. I'm going to have 2x equals 9 minus 5. That's going to give me 4. Okay. Then we are only one step away to get x by itself for this equation. What do? Well, divide both sides by 2. Alright, so in this case we can cancel out the 2's. And get x by itself. Don't forget to simplify this. 4 divided by 2, that's going to give me a 2. And that is final answer. I'm going to look for a better color here, something darker, yet contrasting. So, because I don't like this orange right here, doesn't look very well. Okay, so let's look at another example. Well, what do we have here for letter B? Okay, maybe the most prominent part of this equation is these two parentheses that we have around. So every time you see parentheses there, this is what you might want to do. You might want to use the distributive property there before attempting to do any of the properties we saw before. So I'm going to multiply 8 times y, which is going to give me 8y, and 8 times -7, which is -56. The right hand side of this equation remains the same, 10y minus 56. Alright, so now that we have everything without parentheses or such, we're ready to move variables to the left hand side, constants to the right hand side. It might be a good idea to I don't know, maybe a tip here, I don't know, or idea, that's, or a plan. Alright, so variables on the left hand side. I'm going to use LHS for left hand side, and constant on the right hand side, RHS. Okay, so that's what we're going to do. Does it matter which order do we go? Not really, it doesn't matter. So what I'm going to do first is I'm going to subtract 10y to both sides of the equation. Why do I subtract those 10y? Well, because I have a 10y here on the right that must be on the left. There's no sign in front of it. Well, we take it as a positive. Otherwise, if we saw the negative sign, it would be there. Every time we have the equal sign and no sign at all, then a quantity, it's implied to be a positive quantity. Okay, so we're ready to cancel this out. And 8y minus 10y, well, that's going to give us negative 2y minus 56 equals negative 56. Alright, what's going to happen there? Well, so in this case, let's take care of the 56 and then take care of the negative 2. Let's do one at a time. So I'm going to add 56 to both sides. And look what's going to happen. In this case, these are going to get canceled on both sides. So we're going to be left with the following. We're going to be left with negative 2y equals to 0. And we are only one short step away to get y by itself. Divide both sides by negative 2. And in this case, these go away. And that's going to give us our final answer, y equals to 0 divided by 2. When you remember, when we divide 0 by any number, that's always equal to 0. Alright, well, letter C is a very interesting one. Yes, we have parentheses, and well, how are we going to proceed in this case? Alright, so number one, the left hand side, we have a 9x. Let's just keep it. On the right hand side, we have two terms containing parentheses. So in this case, well, on one group of parentheses, I'm just going to pretend there's nothing, and on another one, I'm going to do the distributive property. Which one is which? Well, keep in mind that this implies a positive sign here. So in this case, we can just take away those parentheses, x minus 8. All right. But in this case, we need to be very careful. Need to distribute the negative along all the terms. So that's going to be negative x, negative times negative plus 2. So that's negative 2. All right. The next step here will be to combine like terms. This is going to go very, very short. Okay. It's going to go very short. Those cancel, and I'm going to have negative 8 minus 2. That's going to give me negative 10. And we are only one step away to get this equation solved. And we do that by dividing both sides by 9. These get canceled, and we get x equals negative 10 over 9. And this is an okay answer. So if we were in a different class, you know, like Math 35 or Math 45, or maybe not even in Math 45, you would be asked to write this as a mixed number. Well, let me just do it real quick. In this case, this is not going to be the requirement. You will not be required to do this, so no need in Math 60. But you might remember this from Math 35 in case you took that class earlier. Alright, let's look at letter D. So letter D, whoa, that has a lot of terms. Alright, so we're going to take care of one side at a time, see what we can do before we start moving terms around from one side to another of the equation. And what catches my eye here, I have excess and excess on the left hand side that I can combine, and likewise I have other excess and excess on the right hand side. So I'm going to combine those two first. So I'm gonna have negative 4x plus 5x, or 5x minus 4x. That's gonna give me x minus 1 equals, on the right hand side I'm gonna have 9x minus 7x. That's gonna give me negative 2x. Alright, well, it's actually positive, not negative. Never mind, let me erase this negative sign, this positive, otherwise it's going to be confusing here. So 2x, and then just drop the plus 3. Okay, so now we have everything ready to be sent. For example, this 2x to the left hand side and this negative 1 to the left hand side, and we do that by adding. I'm going to add 1. Notice in this case I'm moving the constants first, as opposed to the previous examples in which I moved the x's first. The order doesn't matter as long as you do it the right way. That is, whatever you do on one side of the equation, do it on the other side as well. So that's going to give me x equals 2x plus 4. Right, so these two got canceled. And now the next move here is to have these 2x to the left hand side, and we can do that by subtracting 2x on both sides. Cancel, cancel, and x minus 2x, that's going to give me negative x equals to positive 4. It looks like we are done, but we're not done yet. We need to get rid of this negative sign. Keep in mind that when you have that negative without any number, we have a negative 1, an invisible negative 1. And when we get x by itself, we need to divide both sides by negative 1. That way these cancel. And as a final answer, we get x equals to 4 divided by negative 1, which is negative 4. And that's our final answer for this case. Alright, let's move on to another example on the next page. Well, let's see what we have. So, in this case, well, your favorite, perhaps? You love fractions? Well, they're not my favorite either. Well, in some cases, they get to be somewhat tedious, but well, these are nice numbers, and well, I don't think this is going to be a really big deal to go. So what is going to be the trick every time you have fractions? So the trick here is to multiply both sides by the least common denominator, LCD. Okay, so that's going to be the real trick here. Alright, I'm going to put this like that so you can remember what to do in those cases like this. So I'm going to look for a number. The least common denominator is a number that is going to divide the three numbers in the denominator evenly. So for example, let's think of the number 6. Well, 6 divides itself and divides the 3, but it's not able to divide the 4. So I'm going to look for something bigger than 6 that divides all numbers in this case. 3, 4, and 6, and I can think of the number 12. All right. Well, how are we going to deal with this? Well, number one, we are going to distribute this 12 over every single term. Now be careful, because every time you multiply an integer by a fraction, this integer will only multiply with the numerator of each term, not the denominator. I will show you how is that going to be done. Well, I'm going to use 12 in a different color just so you can see how we are supposed to do. X divided by 3 minus the other 12, x divided by 3, and that equals to, actually 4, and 1 over 6 times 12. All right. So in this case, how are we going to proceed here? Well, we're going to do the indicated operations. 12 divided by 3, that's a 4x, and 12 divided by 4, that's a 3x. And then in this case, 12 times 1 is 1, but 12 times 1 is 12. And 12 divided by 6, that's going to give me a 2. And in this case, well, that's the magic touch of multiplying both sides of the equation by the LCD. Those fractions get killed, and we only get a way easier problem to work with. And look, it's gonna go really, really easy at the end, because what is 4x minus 3x? That's gonna give me simply x equals 2, and that's directly the final answer. No more, no less. All right. Well, in this box right here, you have a summary of steps on what to do every time you are to solve a linear equation in one variable. Well, the most prominent thing to do, well, every time we have fractions, just like the previous example, find the LCD. If necessary, use the distributive property to remove grouping symbols, just like the previous examples that we did that contain parentheses. Combine like terms, we did some of those. And then use the property, the addition or the multiplication, those adding or subtracting both sides of the equation by a number, multiply or divide both sides of the equation by another number. And well, in this case, I'm really skipping the last step, which is check the proposed solution. Well, we don't have to do that. Okay, let's do another one. This one is going to be really interesting to do. Okay, so let's see, we have fractions again. All right, so let's see, we have x plus 5, the whole thing divided by 5 plus a half equals 2x minus x minus 3 over 8. Okay, number one, think of this 2x as 2x over 1. Make it look like a fraction. And in this case, we are going to do the same as we did in the previous example. So we are going to look for a number big enough to divide the 5, the 2, and the 8 evenly. So if you want to pause the video and think of it for yourself, that's fine. Otherwise, I'm just going to give you the number. That's a 40. 40 is the number that divides 5, 2, and 8 evenly. All right, so let's see, what are we going to do next? So the next thing we do is use the distributive property, but be really, really careful here, especially with this term and the first term and the last term. So when I multiply the 40 times this whole thing, and then the 40 times this 1, and then 40 times 2x, and 40 times this whole thing called x minus 3. Okay, so let's do one step at a time. I'm going to distribute the 40. So I'm going to have 40 times, Well, be careful. 40 times x plus 5 divided by 5. So in this case, yes, implicitly this 40 will go and multiply both the x and the 5. But if we distribute this even more, we're gonna make this problem more complicated than it is. So I'll show you how to proceed in this case. So 40 times 1, which is 40. That's just 40 divided by 2 equals to 2x times 40. I'm going to write the 2x times 40. All right, I'm going to do 2x plus 40 times 40 rather, and x minus 3 divided by 8. And that multiplies a 40 in front of the parentheses. All right, so let's see. How are we going to proceed here? Number one, again, like I mentioned before, I'm going to divide out 40 over 5. That's a 1 over a 1 and an 8. That reduces to 8. That goes to 1 and goes to 20. And that's 40 times 2. That's going to be 80. I'm going to write it down afterwards. And that's going to be 40 over 8. That's going to be a 5. I mean, a 1 and a 5. All right. So let's write down the result. So that's going to be 8x plus 5 plus 20 equals 40 times 2. That's 80. Minus 5 times x minus 3. Where is this 8 coming from? Where is this 5 coming from? Again, this 8 comes from dividing 40 over 5. That's 8 over 1, or simply 8. And this 5 comes from dividing 40 over 8, which is 5. Okay, so now the most prominent thing that we see here is the parentheses. So what are we going to do about those? Well, distribute and distribute. Be careful with the signs. Be very, very careful with signs. All right. So 8x plus 40. 8 times x, 8 times 5, that's a 40 plus 20. And then 80 minus 5x, actually I forgot the x right here, 8x, okay, minus 5x, and then negative times negative, be careful there. That's a positive 15. Okay, so that's the equation pretty much expanded. Now let's combine like terms whenever possible. For example, we can combine numbers with numbers and x's with x's on each side. So that's going to be 8x, 40 plus 20, that's 60, equals 80x minus 5x, that's 75x, plus 15. Right? Now let's do either way. Either we move the 75 to the left hand side and then the 60 to the right hand side, or we can do the 60 first and then the 75 afterward. Doesn't matter, but I will move the 75 on both sides. So cancel, cancel. I'm gonna get 67 here, negative 67. Next, plus 60 equals 15. And then I'm going to subtract 60 to both sides. You get negative 67 equals negative 45. And finally, to get x by itself, divide both sides by negative 67. But look what's going to happen here. oops, 67. These guys cancel, and negative over negative turns into a positive quantity, 45 over 67. And as far as I know, there's no common divisors between these two numbers, 45 and 67. So we're done with this example here. All right, now let's look at the next page. Let's see what we have. So on the next page, we have a very interesting one dealing with decimals. All right. Well, of course, if you feel comfortable working with decimal numbers, well, you can use your calculator. All right, you can use your calculator, and just make sure to understand what you're doing. Be sure to understand that you are combining constants with constants and x's with x's. However, I'm gonna go with a different method to go about this example. I'm gonna get rid of the decimal places, but how do we do that? So in this case, the trick is to multiply both sides by a power of 10 power of 10. I'm going to write it in letter. A power of 10 to clear the decimals. Alright, what are powers of 10? Well, 10 itself, another a power of 10, well, 10 squared, that's 100. And then 10 to the third power could be 1,000, maybe 10,000. Well, how do we know we have the appropriate power of 10 to clear those decimals? Well, we're gonna look at each term of the equation, and we're gonna look at how many places do we have after the decimal point. So in this case, for the first term, it's a 0.3. That's only one decimal place. 0.1 is only one decimal place, but the numbers on the right hand side, they both have two decimal places. So in this case, we are going to multiply by a power of 10 that has two zeros. In this case, we're going to multiply both sides by 100. All right. If, for example, we had a number with 3 decimal places, then we multiply both sides by 1,000. Or if we had 4 decimal places, well, by 10,000. But in this case, we only require to multiply by 100. Okay, so let's do the distribution. 100 times 0.3, 100 times 0.1, 100 times 0.27, and 100 times 0.02. Alright, let's do the operations here. Well, so 100 times 0.3, that's going to give us a 30x plus 0.1 times 100, that's a plus 10. You might want to verify those using a calculator if you prefer. And then 0.27 times 100, that's going to give me 27x. And plus, actually minus 2, not plus, minus 2. And look, the equation looks a lot more friendlier than the equation we started with. So let's move the 27 by subtracting it on both sides. And that's going to give us 30x minus 27x, that's a 3x. Plus 10 equals negative 2. Now let's see, let's add 10 to both, subtract 10 to both sides. 10, let's erase this sign, make it a minus. That's because that's how it almost looked like a plus. So subtract 10 to both sides, Cancel the 10s. We're left with 3x equals negative 12. And finally divide both sides by 3 to get this canceled. We get x equals to negative 12 divided by 3. Actually, yeah, that is correct. I thought I had a different sign in here. Did I? Never mind. Yeah, that is correct. That's a negative 4. Alright, so that's final answer. So I think this is a good a good number of examples to cover. Basically one of each case. If you, as you can see, one with fractions, one with parentheses, and now we had one with, with decimals. We are going to have special cases of equations and that we need to be able to recognize. Alright, so for example, let's look at these pieces of information. So far, those examples that we did from A through G are conditional equations, and those are conditional because those are called conditional because they have a unique solution. Otherwise, well, an equation with no solution, it's called a contradiction, and an equation with infinitely many solutions, it's called an identity. And we are going to learn how to identify those special cases with the two equation examples below. So let's solve each equation. Alright, so 3x plus 5 equals 3 times x plus 2. So I'm going to distribute the 3 over here because we have parentheses around. So I have parentheses, the left hand side remains the same, and 3 times x is 3x, and 3 times 2 is 6. Alright, so the next step would be to subtract 3x to both sides, and notice how they are going to be both cancelled. And I'm going to be left with 5 equals to 6. And wait a minute, since when is 5 equals to 6? That never happens. What do we have? We have a contradiction. Contradiction, in other words, no solution. Alright, so that's like the second case. An equation with no solution, it's called a contradiction. Or the reverse, a contradiction tells us that comes from an equation that has no solution. Alright, let's look at the other example. Well, what do we have? First of all, we have some parentheses, but be careful, you don't want to add this 2 plus 6 because this 6 is multiplying with the x and the negative 1. So let's see, what do we do first? So we use the distributive property first. That's going to give me 6x minus 4. It remains the same on the left hand side. And 2 plus 6x minus 6. Alright, let's see now, what do we have? So let's combine like terms, and in this case, well, I'm going to combine 2 minus 6, that's going to give me negative 4, so 6x minus 4. So now I'm going to move the x's to the left hand side. Or from here you can call it an identity because you have basically the same quantity on both sides. But if you want to, in a way, simplify it, well, you might want to do that by subtracting 6x first, and goodbye, 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 goodbye. That's going to be then negative 4 equals negative 4, and then I'm going to add 4 to both sides. Alright, and then what's going to happen? Goodbye, goodbye, and another goodbye, goodbye. So final answer, 0 equals to 0. And in this case, well, This is true that 0 equals to 0. That's what we call an identity. Okay. Identity. Otherwise as well, we can call it that it has infinitely many solutions. Alright, and this is a good place to quit for this section. I'll see you on the next video.